So the ones on the left just say write the transformations. Before I can write transformations, I need to know what my base is. So in this first problem, what is my base? The 3 is my base, okay? That has nothing to do with transformation. That's why we circle it so it's out of the way. I have a 4 in an exponent. What does that 4 mean? Who knows? Not one person in here knows what that 4 means. Horizontal compressed by 1/4. Very good. What does the +1 on the inside mean? Left 1. And what else do I have? I have a -2 on the outside. So what does that mean? Down 2. Very good. Number 2 says -7 to the -x. What is my base? Just the 7, not the negative. It's just the number 7. Okay? If I have a negative in front, what does that mean? Reflects the x-axis. Very good. And there's a negative with the exponent. So what does that mean? Reflects the y-axis. Yes, it can reflect both. It just means it flips twice. Okay? Questions on these two problems. All it asked for was your transformations. It didn't ask you for anything else, just transformations. Number 2, or sorry, problem over here, number 2, which is, I guess, number 3, or not number. What is my base? Is it the 4 or is it the 1/2? Why is it the 4? It has the exponent, so my base is 4. What does a base of 4 tell me? It's a growth. How do I know it's a growth? It's larger than 1. Very good. What's the first transformation I see? A vertical compressed by 1/2. I see a -2 with my x. What does that mean? Right 2. And what's the last thing it has? Up 3. Very good. This is an exponential. Exponential asymptotes go with direction. Up and down or side to side? Side to side. If I have an asymptote that is side to side, what axis does it cut in half? The y-axis. So I need to know, how did this graph move in the y direction? What did this graph do? It moves up how much? So where is my asymptote at? At +3. And then the last thing said to create a table. Your table's small because we only have 2 points. What is my first point? 0, 1. And what is my second point? 1, 4, because you have to use your base. 1, 4. Everything else is what we've been doing. Vertically compressed goes on the y side. So I'm going to take half. Half of 1 is 0.5. Half of 4 is 2. If I move right 2, that's on the x. I'm going to add 2. So 0 plus 2 is 2. And 1 plus 2 is 3. And if I go up 3, that's on my y side. So I have 3.5 and 5. Remember, the outside points are what go on your graph. What does the shape of your graph have to look like? A smooth curve, a very good smooth curve, okay? Questions so far? We're moving on today then. So, at the top of your paper, this is still Unit 10, Topic 3. you want to write Unit 10, Topic 3, you can still write that. Today we're doing transformations of logs. Okay, so today we're doing logs. Now, yesterday I told you that your quiz was going to be take home, meaning it's going to be homework, okay? It will be due Thursday, but after I spoke to a few other teachers that teach Algebra 2, we changed it to 5 p.m. So it's going to be due at 5 p.m. But don't worry, because all of you are going to do it tomorrow in class. So 5 p.m. is when the deadline is if you're not here tomorrow, okay? All right, yesterday we talked about asymptotes, but we talked about exponentials. Today we're talking about a log. What direction does a log asymptote go? It goes up and down, it's vertical, okay? James, come on. So if I have something that cuts up and down, it's cutting through the x-axis. Thank you. It cuts through the x-axis. And so something that is up and down has to move in the x direction. So it can only move left and right. Can only move left or right because it's moving in the x direction. Okay. So my parent function is y equals log, look up so you see this, base x. Your base is teeny, teeny, tiny. That's where your base is located on a log, okay? The most important thing to know is if there is no base, it's an automatic 10. So if I don't have a base written, and you'll see that in just a few minutes, it'll automatically be the number 10. We're going to do 2 transformations, and then we're going to do 1 quick graphing problem. So our first problem is going to say y equals 3 log base 4 of x plus 2. 3 log base 4 of x plus 2. So the first thing I need to know is what is my base? That base is 4. Okay, that base is 4. It has nothing to do with my transformations. We circle it, get it out of the way. Here's the next important thing. A log function has no growth or decay. So if it asks you growth or decay, you write none. A log function has no growth and no decay. Okay, let's talk about our transformations. I see a 3 in the very front. What does a 3 in the front mean? A vertical stretch by 3. And I see a plus 2 inside parentheses with the letter X. So that would be left 2. And the last thing we need to discuss is the asymptote. If I have a vertical asymptote, it cuts the x-axis. So how did this graph move in the x direction? Where did it go? It went left 2, so my asymptote is at -2. Very, very similar to yesterday, correct? Y'all have questions, you stop me. Y equals 1/4 log of x plus 6. 1/4 log x plus 6. I need a base. A base is your teeny tiny number next to the word log. What is the base in this problem? It is not 0. It is 10. We wrote up here, if there's no base, it's automatically 10. So my base should be right here, but there's not one, so it's 10. Does this have a growth or a decay? Neither. It has neither. Okay, no growth, no decay. Write that one more time if you need to. No growth or decay. I see a 1/4 in front. What does that mean? Vertical compress, very good, by 1/4. I see a plus 6. Is that plus 6 inside or outside? How do you know it's outside? It's not in parentheses. It's not combined with my x. So what is that plus 6 doing? It's going up 6. And then the very last thing is your asymptote. It's a vertical asymptote, which means it cuts in the x-axis. How did this graph move in the x direction? Did it move? No, so what number is it at? 0, very good. It starts at 0, and if it doesn't move, it stays there. Okay? Questions? Okay, here's what I want you to do. I want you to scroll back up to the top, because next to our word log, we're going to write our parent points. Logs and exponentials are inverse. When you hear the word inverse, what does that mean to us? Flip what? X and Y. So all we're doing are the points we had yesterday. We are flipping them. So instead of 0, 1, I now have a 1, 0. And instead of 1 base, I now have a base 1. I'll tell you the easiest way to remember it. Do you see your first point, how it has a 1 and a 0? That almost looks like I'm writing the word log. So 1, 0, 1, 0. Okay, that's the easiest way to remember your parent points. And then of course your ones have to be diagonal, just like yesterday. Let me flip there really, really quick. Like maybe quick. Like yesterday, our ones were diagonal and exponential. They're just flipped, okay? All right, let's write one quick question. We'll do one graphing. We'll just make the table so that way we know what we're doing. So y equals 3 log base 2 of x plus 1. What is my base? Anybody? My base is 2, that little bitty number. No growth, no decay. What's my first transformation? A vertical stretch by 3. And what else did my graph do? It moved left 1. Very good. I need an asymptote. And it's a vertical, so it cuts the x-axis. Where is this graph going to cut my x-axis? At what number? At -1, because that's how it moved. It moved left 1, okay? Now, yesterday we talked about this, and we said the very first thing you put on that graph is your asymptote. So I'm just going to sketch. It's not going to be pretty. That's okay. Cuts the x-axis at -1. There's, oh, sorry. There's my asymptote. Is that better? All right. Oopsies, a little far. Okay, so let's make our table real quick. Remember, it's a small table. There's only 2 points, x and y. Since this is a log, I need to start my points like I'm writing the word log, 1, 0. Base, My base is 2, and the 1s are diagonal from each other. Everything else we've been doing, vertical stretch by 3, so I'm going to multiply by 3. 0 times 3 and 1 times 3. Left 1 goes in the x direction, minus 1. 1 minus 1 is 0, and 2 minus 1 is 1. Outside points go on my graph. So my first point is 0, 0. And my second point is 1, 3. Now, what makes this graph different? My asymptote is up and down, which means the straight line I draw also has to be up and down, okay? So I'm either totally to the right or totally to the left. Straight line as close to your asymptote as it gets, and then curve into both points. It has to be one curve. You can't have a curve up and a curve down. Very, very similar to yesterday. Are there questions? If you are physically in my classroom, you got this packet, you should have finished page 1. If you didn't, you need to be working on that. Today we are on page 2. If you are on Schoology, this is under topic 3. This is practice number 2, okay? Everybody freeze really quick and look at me because you're gonna ask this question. If you see the letter E, don't worry about, I'm not gonna make you graph with the letter E, but that's an exponential function. You can still get me your transformations, okay? On page 2, the very last graph has an LN. I'm not going to teach you this right now, so you're not graphing, but you can still write the transformations. This is just a different type of log function, okay? So if you see an E or an LN, you're not graphing, but you can write the transformations in the asymptote. Questions? I have now taught you everything in this packet. All 3 pages can be completed. And once all 3 pages are completed, then you can log into your quiz because all 3 pages are on your quiz. So make sure you get those done before you take your quiz. If you finish it, I'll let you take your quiz tomorrow in class before you leave.